If I said, should we invest in the science of aging to help people live healthier, longer lives, maybe some people would say yes and some people would say no. But if I said, should we invest in fighting cancer or dementia or heart disease, probably everybody would say yes. But all three of those and so many other diseases are correlating with aging, and fighting each manifestation of aging is like playing whack-a-mole. One thing doesn't get you, the other thing will. And so it certainly makes sense, at least to me, that we should try to address the underlying biology of aging.
这里是 What If， 这次的主题是如果没有人死亡会怎样？人类预期寿命越来越长了。1910年，美国人的预期寿命只有40到50岁。就在1个多世纪之后，我们的这个数字几乎翻倍，平均寿命达到了几乎80岁。未来主义者孟天行表示，人们正在研究相关技术进一步延长平均寿命。
There's a lot of really exciting work about sequencing, genome sequencing, people who live into their hundreds to see, which is the case, are there genetic differences between those kinds of people and everybody else? And genes instruct cells to make proteins. So what are their genes instructing their cells to do? And can we mimic those kinds of outcomes for everybody else?
如果我们能在所有人身上复制这种现象，那是否可以阻止老年人死去呢？我们的地球会变得人挤人吗？家庭动态会如何改变？为什么我们的医疗系统将会人满为患？在我们想象无限延长寿命的后果之前，先来看看如何达成这个前提。在1个多世纪之内，我们十分可观地延长了人类平均预期寿命，归功于更好的卫生条件、工作环境安全和最重要的医疗。我们有方法治疗致命伤，我们还消灭了一些世界上最致命的疾病。不过，如果我们想要进一步延长自己的寿命，就得去战胜对身体最大的威胁——衰老。
But first, we need to understand what aging is, and there's been some incredible work and great progress in just understanding the basic mechanisms of aging. And there's even a debate raging about, is aging one comprehensive thing, or is it a bunch of different parts, different systems within the human body that are aging at different rates, which is important because you don't want to kind of have an immortal one kind of cell and an immortal other kind of cell, because you'll just be equally dead. So there's some really exciting science, though, about understanding, well, how can we basically shift the way our bodies function and the way our cells function from growth mode into repair mode? How do we put ourselves into kind of the equivalent of screensaver?
相关研究已经开始了，多亏了叫 CRISPR 的东西。它的全名是长间回纹重复序列层级。没听说过吧？我也没听说过，所以还是交回给孟专家来解释吧。
It's an ability to cut and paste, like on Microsoft Word, the genome. The genome is the source code of life, and you can cut it to turn off a gene. You can add genetic material, and that is what allows us to rewrite genetic code. Having said that, genetic code is incredibly complex, and so people shouldn't imagine that we can just rewrite everything. We're in the beginning of the genome editing revolution, but it's moving really quickly.
那么，如果我们可以编辑掉带来最多麻烦的基因，理论上来讲，未来的某一天，我们就能生活在没有人因为衰老而死去的世界中。这不是很棒吗？先别太激动啦。因为现实可不一定有那么简单。我们先来看看利与弊，然后你再决定这是不是个好主意。第一处优点很明显，我们不会再失去那么多深爱的人了，所有人都能万代同堂，其乐融融。家庭将会得到许多帮助，因为这下家长会有很多祖父母、曾祖父母、曾曾祖父母以及许多其他人来帮忙抚养幼儿。如果我们永生，那人们将更加关心未来。这意味着气候变化一类的问题对于老年人来说会变得更重要， 因为他们将体会到自己造成的后果。不过，正如孟天行所说，衰老是件很复杂的事，我们没办法一下子就去掉所有弊端。即便我们解决了一些衰老最致命的方面，我们可能还是得面对不断恶化的骨骼、肌肉和精神。这就得谈谈弊端了。是，我们所有人是能活更久，但过了一定的年龄就只有折磨的话，那有什么好啊？人越老就越需要照顾，我们可能没那么需要医院，但为老年人准备的关怀设施很快就会人满为患。最终，我们将繁殖到超过食物和其他资源供应限度的程度。这时候可能就不得不强制实行生育限制了，而那多半不会有什么好结果。城市也将人满为患，民众动乱会更普遍。更糟的是，这还是在全球人都能平等获得这项科技的前提下。当然，现实可不会是这样。更发达、更富裕的国家将首先拥有这项技术，他们将在制造许多超级人类的路上遥遥领先。这对国际关系来说可能很危险。
The question for us is how do we use this technology wisely, and how do we use it wisely in ways that don't divide populations the way that's completely happened in the past. I mean, when Europe had faster technological advancement than other countries in the world, they used that to colonize and kill people all around the world. I mean, that was that divide. If we don't want that, we just need to make sure that our most sacred values guide the application of our most powerful technologies.
所以，不管你认为这是个好主意还是坏主意，有件事是肯定的：如果我们要追求某种程度的永生，一定要为随之而来的后果做好计划。有可能，那项计划包括我们其中的一部分人移民到隔壁的红色行星上去。不过，那就该是另一期 What If 的话题了。